In the production of wooden barrels, the process begins with careful wood selection, which is a crucial factor influencing the characteristics of the barrel. The chosen wood is then cut into appropriate sized staves, considering the desired thickness and length. The staves undergo milling processes to achieve the necessary dimensions and profiles. Precision cutting and shaping ensure that each stave fits seamlessly with the others during barrel assembly. The staves are jointed to create a tight fit, typically utilizing tongue and groove or dowel joints. The jointed staves are then assembled into the familiar cylindrical shape of a barrel. The assembly requires precision to ensure a watertight seal. Metal hoops are strategically placed around the barrel to secure the staves in position. These hoops play a crucial role in maintaining the structural integrity of the barrel. Additionally, binding material is used to secure the staves before the metal hoops are tightened. Before the final assembly, the staves might be temporarily fixed in place using the binding material. This allows the barrel maker to ensure that all staves align correctly and that the overall shape of the barrel is uniform. The temporary fixing ensures that the barrel is ready for the next steps in the manufacturing process. The assembled barrel is subjected to toasting, a critical step that involves exposing the interior surfaces to an open flame. Metal hoops are placed around the barrel to hold the staves tightly together. The hoops are carefully tensioned, contributing to the overall structural integrity of the barrel. Additional reinforcing elements, such as reinforcing rings, may be added for extra support. The tension on the hoops is crucial for the long-term durability of the barrel and influences its ability to hold liquids without leakage. Assembled barrels undergo a thorough inspection to check for any deviations or imperfections. After the final assembly, the exterior of the barrel is planed and sanded to create a smooth and polished finish. This step enhances the visual appeal of the barrel and prepares it for additional finishing touches. In the final stage, the barrel undergoes a finishing process that may involve the application of a protective coating, such as wax or varnish, to preserve the wood and enhance its appearance. Each barrel undergoes a rigorous inspection to ensure quality, structural health, and compliance with specifications. The process of making cable drums begins with the selection of wood suitable for cable drum production. Commonly used woods include hardwoods such as oak or pine, chosen for their strength, durability, and ability to withstand the weight of cables. Before the wood is cut into a circular shape, the individual components of the cable drum are joined together. This joining process involves connecting the various staves or planks that make up the drum. The joining is typically done by creating precise joints, such as tongue and groove or dowel joints, ensuring a secure and stable connection. After the wood components are successfully joined and assembled, the drum undergoes shaping to achieve a circular form. Automatic saws, equipped with precision cutting capabilities, are utilized for this purpose. The automatic saw is programmed to cut the join wood into a precise circular shape, following the predetermined specifications for the cable drum. CNC machines are often employed in the wood joining and assembly process. These machines are programmed to execute precise cuts and shaping, ensuring that the joints fit together perfectly. CNC technology enhances the precision of the wood joining process, contributing to the overall quality of the cable drum. The individual wood components, known as staves, are then joined together to form the cylindrical body of the cable drum. Various joining methods may be employed, such as tongue and groove joints, dowel joints, or other precise techniques, ensuring a secure and tight fit. This joining process is critical for creating a strong and stable drum structure. Long iron supports are strategically placed around the assembled wooden wheel. These irons provide additional structural support and contribute to the overall integrity of the cable drum. The irons are carefully positioned and tightened to secure the cables in place. The process of making plywood begins with the selection of high-quality plywood. Plywood sheets are carefully inspected for quality and imperfections before undergoing the coating process. Plywood can be coated with a protective layer or veneer, enhancing its durability and providing an attractive finish. The coating also serves to protect the wood from environmental factors. In the dynamic landscape of industrial production, the spectrum of technology adoption among factories is highly varied. While some companies have employed the latest technology to automate various processes, there are also those that maintain a hybrid approach, combining cutting-edge automation with the unique skills of human workers. In the realm of fully automated factories, state-of-the-art technologies such as robotics, artificial intelligence, and smart machinery are harnessed to streamline production. These facilities often boast increased efficiency, precision, and speed. Automated systems handle tasks ranging from assembly to quality control, minimizing errors and maximizing output. However, it's noteworthy that not all factories have fully transitioned to a completely automated model. Many industries still value and integrate human skills into their production processes. Skilled workers bring a level of adaptability, creativity, and problem-solving that machines may struggle to replicate. In such settings, technology is seen as a complement rather than a replacement for human expertise. The industrial landscape is characterized by the diversity of technology adoption. While some factories have fully embraced automation for its efficiency, there are also factories that recognize the irreplaceable importance of human skills. In the process of manufacturing multi-layer engineered floors, it begins with the careful selection of raw materials. High-quality wood veneers are chosen for the top layer, providing the desired appearance and durability. The core layers, typically made of plywood or high-density fiberboard, aim to contribute stability and strength to the flooring. The selected wood veneers for the top layer undergo precision cutting to achieve the desired dimensions. This step may involve slicing or peeling the veneers to the appropriate thickness. The veneers are then prepared for the subsequent layers of the flooring. Adhesive is applied to the wood veneers to create a strong bond between the layers. The type of adhesive used is crucial to ensuring the layers adhere securely, providing stability to the engineered floor. The layers, including the top veneer, core layers, and bottom layer, are assembled in a specific order. The assembled layers move through a press, where heat and pressure are applied. This process activates the adhesive, bonding the layers together into a solid composite. The combination of heat and pressure ensures a strong and durable bond. After pressing, the engineered floor undergoes precision milling. This involves cutting the flooring into precise dimensions and creating the tongue and groove profiles that allow for easy installation. Every batch of engineered flooring undergoes rigorous quality control checks. These checks ensure that each plank meets the specified standards in terms of thickness, dimensions, visual appearance, and overall quality. The final step involves packaging the engineered flooring for distribution. care is taken to protect the finished product during transportation to ensure that it reaches the end consumer in optimal condition.